Section 2, we're going to continue the process of solving linear systems, but in Section 2, we're going to focus on solving using substitution. Okay, so at the end of the day, we're going to have a few different methods for solving linear systems. So far, we have graphing. Now we're going to look at substituting. Okay, so recall that the solutions of a system are the points x comma y that satisfy both equations or each equation. And if you graph it, then that point or the solution is the intersection of the two graphs. So it's to solve the system using substitution, okay? And so when I'm using substitution, I'm looking at the fact that the first equation already says x equals something, okay? So immediately what that tells me is I can replace this x with all of this stuff because we know that x equals all of that, okay? And so what happens here when I look at the second equation, I have 3 times negative 2y plus 2 plus y equals 16. And the way that helps me is now the only variable I have in my equation is y. So I can isolate that and solve for it. So I'm going to distribute my 3. So negative 6y plus 6 plus y equals 16. Subtract my 6 over. Combine like terms. Negative 6 and plus 1y is negative 5y. And then 16 minus 6 is 10. Divide both sides by negative 5. So my y value here is negative 2. And then to find your x value, so I know the y coordinate is negative 2. To find the x, all you do is you take that value of negative 2 and you plug it back into the first equation. So x equals negative 2 times negative 2 plus 2. Negative 2 times negative 2 is 4 plus 2 is 6. And so the point 6 comma negative 2 would be the solution here of this linear system. Okay, so probably a little bit more efficient than graphing because had you graphed, you'd have to rearrange both equations, graph them. Sometimes it's harder to see the intersection points when you're graphing. So this is the second method we're going to be focused on throughout this video. In example 2, you'll notice the second equation already has solved for y. And so what I'm going to do is I'm going to take that and I'm going to solve it into the first equation. So 5x minus 4 times, now instead of y, I'm going to put in 6x plus 5. Equals negative 1. So I have 5x minus 24x minus 20. I distributed my negative 4. Okay. So I have, when I combine these guys, that ends up with negative 19x. When I add 20 to both sides, I get equals 19. Divide both sides by negative 19. X equals negative 1. So the x coordinate is negative 1. And again, I'm going to plug that into my second equation. So y equals 6 times negative 1 plus 5. So y equals negative 6 plus 5, which tells me that y is equal to negative 1 as well. So the point negative 1 comma negative 1 is your solution. Again, you can check your answers all the time. Just plug negative 1 in for x and y in both equations, and it better work out. If it doesn't, well then clearly you kind of had a misstep somewhere. Example 3. Now you'll notice here this isn't as straightforward because neither one of the equations say x equals or y equals. So what you're going to want to do is solve for x or y in either one of the equations. Now in this one, to me, it's a lot easier to work with the first equation than it is to work with the second equation. All right, and it doesn't matter which one you do. I'm going to go ahead and just get y by itself. So I'm going to subtract x from both sides. And so I end up with y equals negative x plus 5. And now this guy here is what I'm going to use to plug in for y there. Okay, so I have 7x minus 9 times negative x plus 5 equals 3. And now I can solve for x. Okay, so 7x, distribute your negative 9, so you get positive 9x minus 45 equals 3. Add your 45 to both sides. So you get 48. And then on the left-hand side, you get 7 and 9 makes 16x. Divide both sides by 16 says that x equals 3. So the x coordinate's 3. And then I'm going to take that x, I'm going to plug it back in. You can plug it really into wherever you want, but I'm going to take it right here because I've already solved for y. So y equals the opposite of x plus 5, and negative 3 plus 5 is just 2. So 3 comma 2 is the solution of this system of equations. Okay, at this point I would probably pause the video and watch it, try the problem, and then watch the video to kind of reinforce or check your answers. So when I look at this set, or the system, I look at the second equation, I say I can get y by itself easily. All I have to do is subtract 2x from both sides, and I'm done. Okay, now I take that value of y, this negative 2x minus 3, and that's what I'm plugging in here. So I get 4x minus 2 parentheses negative 2x minus 3 equals 14. Distribute, so I get 4x plus 4x plus 6 equals 14. 4x and 4x makes 8x. I'm just going to go ahead and subtract my 6 to make life a little bit easier. I shouldn't have an x on the right hand side. So I get 8x equals 8. Divide both sides by 8, x equals 1. And I take that value of 1 and I just plug it in here. I get negative 2 times 1 minus 3, which is negative 2 minus 3, which is negative 5. So the point 1 comma negative 5 is the solution to this system of equations when you solve it. Now you could have taken the first equation and subtracted the 4x and then divided by negative 2 to get y by itself, or you could have gotten x by itself. It's not going to matter either way. It's just a matter of what you prefer to do. You'll have to do a little bit more work there, that's all. As we take a look here at the next example, it's a story problem. So it says, a county fair sold children tickets and adult tickets. 6 times as many children tickets as adult tickets were sold. Children tickets cost $5, adult tickets cost $8. The total tickets cost $39.14. So you got to set up your system here, okay? And the first thing I see is that there were 6 times as many children as adult tickets. So that means the number of adult tickets was 6. I goofed that up. The number of children tickets was 6 times the number of adult tickets. There's 6 times more children, okay? And then the second part of it is I know that each children's ticket costs $5 plus each adult ticket costs $8, and when I add those two things up, it's got to equal to $39.14 in total sales. And so now what I can do is I can just simply replace C with 6A. So I have 5 times 6A plus 8A equals $39.14. So now here I do 5 times 6, that's 30A plus 8A equals $39.14. And that simplifies to 38A equals $39.14. Divide both sides by 38, so $39.14 divided by 38. $39.14 divided by 38 is, the number of adult tickets was 103. And the number of children tickets, all I got to do is plug that 103 back in here. So I do 6 times 103, and I get 618 children tickets. All right, and that's all we're looking at here in this particular problem. So again, set up your system, solve your system in this particular example using substitution.